All right, so most equations are really simple to balance, but some redox reactions actually happen in acidic conditions and basic conditions, and because of that, it makes it a little bit more complicated, but there are some steps to balance some of these really complicated reactions, like this one. This one is a very complicated reaction, but if you follow some steps and just go really slowly, make sure you double check every step, then it's not that bad. It's just it can be a tedious process, but if you just follow all the steps, then it's fine. All right, so these are the steps to balance a redox reaction in acidic conditions. And if it's going to be in acidic conditions, they have to tell you or indicate that somehow. So here are your steps. You're going to be given an equation. You're going to actually write the half reactions from that equation, one for reduction, one for oxidation. Then you're going to balance all the other elements besides H and O. So besides hydrogen and oxygen, balance everything else. Then to balance the hydrogens, you're going to add H pluses to the equation. You're going to balance oxygen by adding water. And then after that, you're going to balance the charge by adding electrons. And then if the electrons do not cancel, you're going to multiply the reactions by numbers so that they will cancel. And then just put the half reactions together. All right, so let's look at this one right here. We're going to write the half reactions first. Okay, so if you look at this too, it seems like it should be balanced, except you've got oxygen here and then there's no oxygen on this side. So that's why we have to go through and balance it. So we're going to look for the oxidation and the reduction reaction here. So let's look to see what has been oxidized. So what thing has had the oxidation number gone up on? Well, before I do that, let's make sure we know what the Mn's oxidation number is here. So oxygen is -2. There's 4 of those, so it's -8. And overall, this whole thing has to be -1. So what plus -8 will give me a -1? That should be 7. And since there's only one manganese here, it's going to be a +7. So manganese went from a +7 to a +2. Its number went down. Oxygen, I'm not going to worry about that right now. It's not on both sides, so we can't say if it's being oxidized or reduced, and it's not going to be. And then you've got a +2 and a +3 here. The number went up, so that is what's being oxidized. So iron is being oxidized. Well, what's being reduced? The Mn goes from a +7 to a +2, so that means that it's being reduced. So let's write the half reactions now. Well, for oxidation, it goes from this to this. And I'm not worried about balancing this yet. I'm just writing out the half reactions. I'm going to come back and balance everything in a moment. All right, so for reduction, well, MnO4, we're looking at the whole thing here, goes from this to this. And you want to make sure that you are putting these charges every step of the way. Do not miss any little thing, because if you miss putting that -1 charge there, later down the line when you're trying to balance everything, it's going to make life hard on you. All right, so those are our 2 half reactions. So now we're going to focus on balancing each half reaction. All right, so let's look at the iron first. Well, okay, the ions are balanced. Fe is balanced. And there's nothing else. There's no H's or O's, so I can't balance that. So all I need to worry about is balancing the charge by adding electrons. So it went from a +2 to a +3. So I need to decide, where do the electrons go? Well, in order for it to become more positive, I would have to take out an electron. Also, if I'm just trying to balance the charges, one of the ways that I can do that is adding an electron on the side. So in order for it to become more positive, you are taking out an electron. So you're going to have the electron on your product side. And now you can add up the charges to see that they're equal. You've got a +2 on this side, and here you've got a +3 and a -1. So that overall should be +2. So now your charges are balanced. All right, so I'm done with this equation for now. So let's look at the next equation. All right, so let's look at this one. This is our other half reaction. I've got MnO4 with a -1 and then Mn with a +2. Well, my manganese is balanced, so I don't need to worry about that. Now I'm going to balance the O's by adding water molecules to it, because that's what ends up happening. When you have a reaction like this and an acid, you have an acid, so you have H+, and you also have oxygen, or oxygen in the form of water. So if you are in an acid, there's H+ ions and there's also water. Okay. Okay, so we're going to balance this by adding oxygen, by adding water. So you've got 4 oxygens on this side. So water, remember, is H2O. You would need 4 of these to get 4 oxygens. So I'm going to add 4 waters here. So now I have 4 oxygens on this side, and I also have 4 oxygens on this side. But now I've introduced something else. I've introduced hydrogen into the reaction. So I'm going to balance this by adding H's, or H pluses. So I've got 8 hydrogens on this side. So now I'm going to go back and I'm going to add 8 hydrogens on this side. But it's going to be H+. And this is because it's an acid. Acids donate hydrogen ions. So now let's see. I've got 8 hydrogens here, 8 here. I've got 4 oxygens, 4 oxygens. So every element is balanced. So now I need to look at the charge. So I've got +8 here. I've got a -1 overall here. I've got a +2 here, and then I've got a 0 for this. Okay, so I've got a +2 and a +7. So I need to bring the charges, I need to bring electrons into this equation to get the charges to balance. So I've got a +7 on this side right now and a +2. Well, I need to get this side down, and I've got electrons, which are negative. So I'm going to add electrons to this to make the charge go down. So I need it to go down to a +2. So I'm going to do that by adding 5 electrons. So that means I'm adding -5 to that. So that's -5 plus -1, which is -6, plus a +8 would give me a +2. So I need to add electrons to make this side less positive. When you have electrons, you can't add them to this side because that would just bring the charge down. That's not going to help you. So you look at this side with the larger positive charge and add electrons to that side. All right, so now that our charges are balanced, all the atoms are balanced, this is our new half reaction. Now we're going to look at the 2 half reactions together. Okay, so now these are our 2 half reactions we just came up with. Now what we're going to do is we're going to look at the number of electrons and see if they cancel. So I have 5 electrons on my reactant side here, and then 1 electron on this side. So right now they're not going to cancel. So I'm going to multiply to get the number of electrons to be the same. And remember, when you do this step, you multiply the entire equation. So we have Fe with a +2. All right, so now we're going to multiply this entire equation by 5, because I've got 5 here, so 5 times 1 would give me 5 electrons. So 5 here, plus 5 electrons. All right, so this is my new equation. And at this point, I've got 5 electrons, 5 electrons. I'm going to combine them together. So I'm going to take this equation and put them together. And electrons should cancel. So I've got 5 electrons on the product side, 5 electrons on the reactant side, so that will cancel. And nothing else is the same. So I can basically just combine everything together. So if you have something that appears on both sides, then you probably need to go ahead and do some more canceling too. All right, so 5 Fe positive 2, that's it for that side, plus 8 hydrogens, plus 1 permanganate. Don't forget the negative sign. That's it for the reactants on that side. That's going to give me Mn with a positive 2 plus 4 waters plus the irons here. All right, so now I have my combined equation. I'm just going to double check everything by making sure the charges still cancel on both sides. So I've got 5 times positive 2, which will be positive 10, plus 8 times positive 1, which would give me positive 8, and then a negative 1 here. All right, so on this side, I've got a positive 2, and I've also got 0. And then here I've got 5 times positive 3, which is positive 15. Okay, so now I've got so now I've got 10 plus 8, which is 18, minus 1, which would be positive 17 on this side, and then I've got positive 2 plus 0 plus 15, which would be positive 17 on this side. So the charges cancel, hallelujah, you can move on. If they do not cancel, you need to go back and look at all your steps. This is why it's important to make sure you go through every single step, double check it, make sure you pull the charges down. All right, so I advise if you're watching this, pause the video, try to do the next one on your own. And we just did that, so. All right, so here's the next reaction. Pause it, try it on your own. All right, so now we're going to write the half reactions for this particular equation. So let's decide what's being oxidized, what's being reduced here. This one, our charges aren't included, so we need to go through it. All right, so potassium is a +1, and it's in a ternary ionic compound, so I need to look at this right here. I know it's an ionic compound. It's got SO4 in it. SO4 is sulfate with a -2 charge. So overall, SO4 needs to add up to -2. All right, so sulfate has oxygen in it. Oxygen is -2 normally. -2 times 4 would be -8. So in order for this whole thing to add up to -2, -8 plus what would give me -2? That should be +6. All right, so now let's look at this one. Well, chlorine is -1, so sodium's a +1. Here, chlorine is a 0. And then in this one, the charges have to equal -2. So it goes from oxygen's -2 times 3 would give me a -6. And it overall needs to equal -2 because that's the charge of the ion. So what plus -6 would give me -2? That should be a +4. All right, so now we need to figure out what's being oxidized, what's being reduced. So let's look for the reduction first. Okay, so now Okay, so reduction happens with, let's see, with sulfur. So it goes from a +2 or +6 to a +4. So the reduction is happening with the sulfur. And then the oxidation well, let's see, which number is going up? Well, chlorine went from a -1 to a 0, so it was being oxidized. So we need to figure out what the reduction reaction is and what the oxidation reaction is. All right, so reduction happens with sulfur. So what we have on the reactant side is going to be K2SO4. And on the product side, it becomes SO3 with a -2 charge. All right, so this is our half reaction for the sulfur. Let's look at chlorine. We're going to worry about balancing it in just a second. Let's get the reactions written first. So on this side, chlorine is NaCl. On the reverse side, the product side, it's Cl2. All right, so now those are our half reactions. We're going to focus on balancing one at a time. Okay, so here's our first half reaction, K2SO4, and that produces this. Okay, so, and automatically I notice there's a problem. I've got potassium here, and I don't have it on the other side. So I need to fix that. And what I'm going to do is I'm just going to add potassium ions, because what ends up happening is that it just separated in the solution and became an ion. So I've got 2 Ks on this side, so I'm going to go over here and add 2 Ks with a +1 charge because they're ions. And when you have an ionic compound in a solution, remember they will dissociate into their ions. All right, so my other elements are balanced. So now let's look at the oxygens. All right, so I've got 4 oxygens on this side. I've only got 3 on this side, so I need to fix that by adding water. So I've got 4 in this, I've got 3 here. Need to add 1 more, and H2O has 1 oxygen, so I'm going to add 1 water molecule here. Well, now I've introduced hydrogen, so now I need to go back and balance that by adding H+. So I've got 2 hydrogens here, so I'm going to come back to this side and add 2 hydrogen ions. So now I've got 2 hydrogen ions, 2 on this side. I've got 1 oxygen plus 3 right here, so 4 oxygens. My sulfur's okay, my potassium's okay. So now I need to look at the charge. So I'm going to look at my charge of everything. I've got +2 here, 2 times +1. Overall 0 charge for this. I got a -2 charge for this, +2 charge for this, and a 0 for this. So I've got +2, -2, that's a 0 charge on this side, plus a 0. And then I've got a +2 on this side. So I focus on the more positive side and I add electrons to it, because I can't add electrons here and make the numbers go down. But I can add 2 electrons to this side to make it equal 0. 2 times -1 would give me -2, plus a +2 would give me a 0 overall. All right, so that's my first reaction. So now I'm going to come back to that after I look at the other reaction. Okay, so this one, NaCl produces Cl2. All right, so I do need to worry about something here. Sodium is on this side and not on this side, so let's fix that first. Okay, so I've got sodium here, so remember it's a sodium ion. All right, so now Cl2, I've only got 1 chlorine on this side, so I've got to fix that too. So 2, 2, and then of course I have to have 2 on that side for sodium. All right, so now I don't have any H's or O's to worry about here. So now I just need to look at the charge. All right, so now I've got a 0 charge here, 0 here, and then a positive 2 on this side. So remember, this is the more positive side, so I'm going to add electrons to it to make it equal this charge. So positive 2 needs to be brought down to 0. I'm going to add 2 electrons to make it equal 0. So this plus this would give me a 0. So this is my half reaction for the chlorine. All right, so now let's look at the reactions together. All right, so here's my reaction here for the sulfur, and then this is my reaction for this. So now what I need to do is I need to figure out, do the electrons cancel. I've got 2 electrons here, 2 electrons here. So I don't need to worry about that canceling, so now I'm just going to add the half reactions together. So 2 electrons will cancel. I need to see if anything else will also cancel, because sometimes things will appear on both sides, and if they do, that means I can cancel them. Hydrogen, there's no hydrogen here. That doesn't appear on both sides. That's not there. Okay, so this is pretty easy. So now I'm just adding them together. So it's 2 H pluses plus K2SO4 plus the reactant here, 2 NaCl, produces SO3 with a -2, oops, not positive, plus 2 potassiums, plus water, and Cl2 plus 2 positives. All right, so now we need to make sure the charges are equal. So we have positive 2 here, 0 overall here, 0 overall here. I have a negative 2 right there. I have a positive 2 right there, 2 times positive 1. I have a 0 here, I have a 0 here, and then I also have a positive 2 on this side. So these two cancel. I'm left with a positive 2, and then I also have a positive 2 on this side, so hallelujah, I'm done. You have to go back and double check this because it's very easy to miss something when you do this. So make sure that you're checking and you're doing it slowly, and at the end, make sure your charges are equal. If they do, you've done it correctly.